For half a century, the moon was a ghost town, a silent museum preserving the footprints and flags of a bygone era. The grand celestial ballet seemed to have paused, leaving us with memories of giants who once walked another world. But as we stand at the threshold of a new age, that profound silence has been shattered. The quiet era of space exploration is definitively over. Right now, a complex and growing web of technology encircles both the moon and Mars. There is more sophisticated hardware orbiting these worlds, descending to their surfaces and analyzing their secrets than at any point in human history. This isn't a tentative return, it's a full-scale strategic deployment of infrastructure. We are building the scaffolding for a permanent off-world presence. The paradigm has shifted. We aren't just visiting anymore, we are moving in. This is no longer about planting flags and collecting souvenirs. It's about establishing a foothold, creating self-sustaining outposts, and unlocking the resources that will fuel our expansion into the solar system. From the frantic hunt for water ice, the white gold of the lunar South Pole, to the first autonomous factories printing habitats on the red planet, the ground truth of space is evolving faster than the headlines can keep up. This new chapter is being written not by astronauts alone, but by robotic pioneers, AI-driven systems, and a global consortium of public and private enterprise. The dreams of science fiction are becoming the engineering problems of today. So, what does this new reality actually look like? Today, we're looking past the mission patches and press releases to reveal what is actually happening right now on the moon and Mars. We'll explore the machinery, the science, and the sheer ambition driving humanity's next great leap. The biggest story on the moon isn't the view, it's the water. For decades, we thought our nearest celestial neighbor was bone dry. But we were looking in the wrong places. The real treasure is locked away in the deep frozen craters of the South Pole, in regions of eternal darkness. These are the permanently shadowed regions, or PSRs, where the sun has not shone for over 2 billion years. Here, temperatures plummet to a staggering minus 230 degrees Celsius, just 40 degrees above absolute zero. This extreme cold acts as a perfect trap, preserving billions of tons of water ice mixed in with the lunar soil, or regolith. We confirmed its existence in dramatic fashion. In 2009, NASA's LCROSS mission slammed a rocket stage into the Cabeus crater, kicking up a plume of material that was analyzed for water. The results were definitive. Orbiters like the Lunar Reconnaissance Orbiter, or LRO, have since used instruments like radar to map these deposits, giving us a treasure map for a new era of exploration. Now, a new space race is on. NASA's Artemis program and China's International Lunar Research Station, or ILRS, are targeting the very same ice-rich locations. The reason is simple. Water is the oil of the solar system. Through a process called electrolysis, water can be split into its core components: breathable oxygen for life support, and liquid hydrogen and oxygen, the most powerful chemical rocket propellant known. The vision is to turn the moon into a cosmic gas station, a critical refueling point for the deep space economy. But first, we have to solve a major engineering challenge. How do you mine ice in a vacuum without it instantly turning to vapor and disappearing? By 2026, missions like NASA's Prime 1 will test autonomous drills designed to excavate the icy regolith, while a cold trap captures the vapor before it escapes. Other concepts involve using microwaves to heat the ice from within the soil, a process called sintering, which could prove even more efficient. Once extracted and processed, this lunar-derived propellant can be stored in cryogenic depots on the surface or in orbit. From there, small, reusable tankers can hop between the lunar surface and an orbiting station, like the Gateway, refueling spacecraft destined for Mars and beyond. This single resource fundamentally changes the economics of space travel, making the entire solar system more accessible. If you landed on the moon today, you might get a signal. Nokia is currently deploying the first 4G LTE communication system on the lunar surface. Why it matters? High-speed data is required for the fleets of robotic rovers that are currently mapping the terrain. Powering the night. The lunar night lasts 14 Earth days and is freezing. To survive, NASA is developing fission surface power, small portable nuclear reactors that can provide constant energy when solar panels go dark. The moon is becoming a 24/7 industrial zone. Moving 140 million miles away to Mars, the focus has shifted from simply looking for life to the audacious goal of bringing Mars home. For decades, rovers have acted as our remote geologists, but their onboard instruments, while impressive, are no match for the full power of Earth's most advanced laboratories. To truly unlock the secrets of the Red Planet and search for definitive signs of past life, we need to get our hands on it. The first step is already complete. On the floor of Jezero Crater, the Perseverance rover has meticulously collected and sealed a pristine cache of Martian rock, soil, and even atmospheric samples inside dozens of titanium tubes. These aren't random souvenirs. Each sample was chosen for its scientific potential to tell a story about Mars's ancient watery past. They now lie in a carefully selected depot, a geological treasure chest awaiting pickup. The next phase is the Mars Sample Return Mission, the most complex interplanetary delivery service ever conceived. The plan involves a sample retrieval lander, touching down near the cache. From it, small, agile fetch rovers will retrieve the tubes and deliver them to a critical piece of hardware, the Mars Ascent Vehicle, or MAV. This two-stage solid-fuel rocket is designed to perform a feat never before attempted, a launch from the surface of another planet. It will carry the precious sample container into Martian orbit, a pivotal moment in the history of space exploration. Waiting in orbit will be the Earth Return Orbiter, which will perform a delicate, high-stakes rendezvous to capture the container. After securing its cargo, the orbiter will fire its engines for the long journey back. As it nears our planet, it will release a specialized Earth entry system, a capsule designed to protect the samples from the fiery heat of atmospheric re-entry. Upon landing, the samples will be transferred to a highly secure biosafety facility, ensuring planetary protection. We aren't just looking at rocks through a camera anymore. We are preparing to analyze them with a precision and depth impossible anywhere but here, on Earth. Sending bricks to Mars is too expensive. The secret to living on the Red Planet is in situ resource utilization. The tech, companies like Icon are testing 3D printers that mix Martian soil with a binding polymer to create Marscrete, the shield. Because Mars has a thin atmosphere and no magnetic field, these homes aren't built on the surface. They are covered in meters of soil to protect against radiation. As of 2026, we've successfully proven that we can manufacture building materials out of Martian dust. The first Martian suburbs are already being designed. The moon is our training ground. Mars is our destination. What's happening right now isn't just science. It's the beta test for human expansion. In 10 years, going to the moon won't be a news event, it will be a job description. The question, if you were offered a one-way ticket to live in a 3D printed Mars base, would you take it? Or is Earth the only home you'll ever need? Let me know in the comments. Don't forget to subscribe for more updates on our journey into the stars. I'll see you in the next one.